We talk about AI constantly. I mean, it's just the background noise of modern tech now, right?
Oh, absolutely.
It's in our pocket, it's driving our recommendations, it's personalizing everything we see online.
And it's giving us these instant, sometimes scarily accurate answers.
Exactly. It's just become this shorthand for anything that looks smart in software.
And, for anyone leading a project or managing a budget, that term, AI, has become, well, a little too blunt. It's not specific enough.
Right, if you're trying to figure out what you're actually paying for.
Precisely. The intelligence you're seeing isn't all created equal.
Yeah.
And if you mistake really complex engineering for true learning, that can be a very expensive mistake for a project.
Millions of dollars expensive. And it's not just budget, it's timelines. It's the risk you're taking on, your whole strategy, really. We have to ask, is this thing actually learning or is it just brilliantly programmed?
And that's our mission in this deep dive. We want to give you the language to answer that exact question. We're going to separate complex automation from genuine machine learning.
And how are we going to do that?
We're going to use a really useful framework, a concept we're calling perceived AI. It's your shortcut to understanding why some systems look intelligent, but operate under completely different and much more predictable rules.
Okay, let's unpack this. So let's start with that definition. Perceived AI. It sounds a little bit like a magic trick.
In a way, it is, but it's a trick of engineering genius, not deception. Perceived AI is intelligence that is entirely 100% hard-coded.
Hard-coded, so written by a person.
Written by a person or a team of people. It achieves these incredibly sophisticated outcomes. Personalization, complex answers, not through learning, but through deterministic, explicitly programmed logic.
So we're talking about massive sets of rules, like if this happens, then do that.
Millions of them, sometimes, interconnected if-then-else statements or incredibly complex scoring systems.
Yeah.
The key is the system isn't discovering anything new on its own.
It's just executing its instructions at, lightning speed.
That's the core difference. Its brilliance is a function of human design and foresight. The engineers had to think of almost every possible path a user could take. It's what we call deterministic genius.
I love that phrase, deterministic genius. And I think this is where the Swiss watch analogy really helps clarify things for people.
That's a perfect analogy.
You think about a beautiful mechanical watch.
Yeah.
It can track moon phases, calendars, different time zones. It's a miracle of engineering.
It absolutely is. Yet every single gear, every spring is completely predictable. It was all explicitly designed.
Right. No part of that watch is going to spontaneously decide to start tracking Martian time.
Never. There's no learning. There's just perfect engineering executing on a fixed set of mechanics. That is the essence of perceived AI.
And the result is that the user perceives the system as being intelligent because the output is so specific, so non-random, it feels like it knows you.
It simulates the outcomes of intelligence so well that the business goal is achieved. And for a decision maker, that's a critical realization. If a rule-based system can solve 90% of your problems, you save so much money by sticking with that.
So that brings us to the big operational advantage then. Predictability. How does that help when I'm, say, scoping out a project?
It gives you certainty. Total certainty. The system's behavior is 100% predictable if you know the rules and you know the input. And it's not just convenient, it's a huge strategic asset.
And we really do interact with these systems every single day without thinking about it. So let's get into some specific examples where perceived AI is what's really running the show.
These are the workhorses. High-value, high-accountability systems.
Okay, let's start with simple recommendation engines. On a shopping site, we tend to think that's some deep neural net, but often it's just really elaborate if-then-else logic.
Exactly. The rule is hard-coded. If a user bought item X and has Y in their cart, then recommend Z. It's just very sophisticated filtering.
The algorithm didn't learn that relationship on its own. Some analyst or merchandiser figured it out from sales data and wrote it into the code.
And that fixed logic is key. What about basic chatbots or IVR systems?
The ones that make you want to scream representative into the phone.
Those are the ones, they don't understand nuance. They rely on these huge decision trees and pre-written responses. It's just mapping keywords to answers.
Yeah.
If customer says cancel, go to script 4B.
And that rigidity can lead to some really funny situations. I remember reading about a guy who moved from Minnesota to Florida.
Yeah.
And for 2 years, his recommendation engine kept pushing snow shovels on him. The rule was just so rigidly tied to his old address, it couldn't adapt to the fact that he was now in, the Sunshine State.
That is a perfect example of the limitation. The system is only as smart as the foresight of its programmer. If they didn't write a rule for what if someone moves, the old rule just keeps firing. But you can trace that failure back to a specific line of code.
Which brings us to a really high-stakes example, traditional scoring and lending
Oh
systems.
yeah, in finance, this is huge.
See, when you apply for a loan, your credit score isn't a guess. It's a formula, right? A weighting and summation of variables like your debt, your income.
It's an explicit, auditable mathematical formula. The system isn't making a probabilistic guess about you. It is calculating a score based on fixed logic that regulators often demand be totally transparent.
And one more, what about configuration tools, like when you build a custom car or a PC online?
That's all combinatorial logic. It's managing millions of options and dependencies to make sure you can't, say, pick an engine that doesn't fit in the car's frame.
Yeah.
That's not learning. It's just deterministic genius at a massive scale.
So the common thread here is total transparency, traceability.
It's the single highest value proposition of perceived AI, especially if you work in a regulated space like finance or healthcare. Compliance is mandatory
Why is that so critical?
because you have to be able to explain why a system made a decision. If a loan is denied, you have to give a reason. With perceived AI, you can point to the exact rule. Loan denied because debt-to-income ratio exceeded the threshold in Rule 14b. It's a clear, auditable path.
Okay, so if perceived AI is so brilliant, so transparent, and so much cheaper, why does anyone bother spending billions on true AI? Here's where it gets really interesting.
Right, because at some point, the problem becomes too big, too dynamic for humans to write all the rules. That's when we stop engineering and we start learning.
So define true AI for us, machine learning, deep learning. What's the difference?
It's a completely different approach. True AI is not programmed with rules. It learns the rules itself
How?
by processing just massive amounts of data with statistical models. When we talk about training a neural network, we're basically saying, here are a million examples of inputs and the outputs we want. You figure out the patterns that connect them. The model writes the rules for you.
And that creates what you call the adaptation divide. With perceived AI, if the market changes, a programmer has to go in and manually rewrite the code.
Which gets exponentially harder as the system grows.
Yeah.
But true AI, if you feed it new, labeled data, it adapts automatically. It finds the new patterns and adjusts itself.
Okay, I have to challenge that a little. We always hear it adapts automatically, which sounds so easy, but the adaptation isn't free, is it? Our sources really highlight the huge hidden cost of true AI.
That is such a vital point. The data.
The data itself.
True AI makes probabilistic predictions based on patterns, but to find those patterns, it needs labeled data, and that means you need humans.
Right.
Lots of them. Right? Meticulously labeling millions or even billions of data points so the model knows what a good outcome looks like. It's a massive ongoing operational cost.
So perceived AI has a big upfront engineering cost, but lower data costs later. True AI might be cheaper to start engineering-wise, but it has this huge sustained data and maintenance cost.
Exactly. And that's the tipping point for a project leader. At some point, the cost of having 20 engineers manually updating a million IFN rules becomes more than the cost of collecting the labeled data to train a model. That's when you make the switch.
And what about that transparency we like so much? What happens to auditability with true AI?
You lose it. Or it gets much, much more complicated. With these deep learning models, the explainability can be very low. The system made a decision based on weighting billions of parameters, but the specific path it took is often opaque. We call it the black box.
And that black box introduces a risk that perceived AI just doesn't have, right? Something called model drift.
Model drift is so important to understand. The true AI model learned from historical data. If the real world changes, say a pandemic completely alters shopping behavior, the model's predictions might start getting worse because the old patterns no longer apply.
So it needs constant monitoring and retraining. The perceived AI system, being fixed, doesn't drift. It just becomes obsolete if the rule itself is no longer useful.
If we connect this to the bigger picture, this distinction really matters for anyone making strategic decisions. It boils down to three things: cost, risk, and scope.
Let's start with scope. How does this change how you'd start a project?
It lets you be realistic. You can stop chasing the most complex, flashy solution. Like we said, perceived AI is often much faster and cheaper to build at first. You can use that brilliant engineering to solve 90% of your problems without that huge data investment.
So if I'm building a customer service system, I don't need a cutting-edge AI to handle the first step. I can use perceived AI like keyword matching to route 80% of the calls and only send the really tricky ones to the more expensive true learning model.
Precisely. You're building a hybrid system. That's where the future is. You use the reliable, auditable, perceived AI layer to handle the bulk of the work and save the expensive true AI for the parts that actually need prediction and learning.
And what about risk? How should a leader weigh that 100% control of perceived AI against the maybe better results from true AI?
It's a liability calculation. In finance or insurance, a mistake can have enormous legal consequences. In that case, the ability to maintain 100% control and trace the exact decision rule is everything.
So you might accept a slightly less optimal result.
In exchange for ironclad accountability, yes. True AI might give you 2% better accuracy, but the black box liability might just not be worth it.
So the strategy here is really to stop reflexively reaching for the most complex tool in the box. Use brilliant engineering perceived AI for immediate auditable value and save true AI for the genuinely ambiguous, evolving challenges. So what does this all mean?
It means the language we use matters. The key takeaway for you is to always ask where the intelligence is coming from. Is it from complex, explicit engineering, our perceived AI, or is it from genuine pattern learning on massive data sets, our true AI? They're both valuable, but they have completely different costs, timelines, and risks.
And now you, the listener, have the advantage. When someone comes to you with a new AI project, you can ask the right questions. Are we building a hard-coded system that needs big upfront engineering, or a statistical model that needs continuous labeled data? That one question defines the entire project.
And here's a final thought for you to take away. We now know that systems like credit scoring algorithms are 100% predictable. They're based on a fixed, traceable formula. So how might, knowing that the outcome is totally engineered and not learned, change your approach when you interact with a system that's judging you or trying to guide your choices? If the rules are rigid, can you optimize your input to get the outcome you want? Are you dealing with a clever decision tree or a true learner? The difference changes everything.